Astronomers studying a spiral galaxy in the constellation Fornax have found a clue not only to why stars are still forming today, but why ones the age of our Sun even exist at all. Under the standard Big Bang theory of the universe's origins, everything began 13.8 billion years ago, when a titanic explosion flung matter and energy out in all directions. As the universe expanded, a lot of other things occurred in its early years, including the formation of galaxies, giant gas clouds, and stars. In the process, most of the star-forming material in galaxies should have condensed into stars long ago, when the universe was only a fraction of its present age. But that is simply not the case. More than half of the galaxies we see, including our own, are actively forming stars right now. And some, known as starburst galaxies, are doing so very actively. Furthermore, our own Sun is only about 4.6 billion years old, or 1/3 the age of the universe. That makes it young, given the fact that the starbirth rate probably peaked before the universe was much more than a billion years old, says Fatima Tabatabaye of the Instituto de Astrofísica de Canarias in the Canary Islands. Clearly, something must have slowed the rate of star formation, a process known as star formation quenching, preserving star-forming matter for future generations of stars. In order to study this process, a team of astronomers led by Tabatabaye turned their attention to NCG 1079, a galaxy that at a distance of 45 million light-years is bright enough to have been discovered in 1790 by British astronomer William Herschel, who only a few years earlier had found the planet Neptune. It was picked partly because it is close enough to be studied in detail, Tabatabaye says, but also because it shows signs of quenching, even though it is still forming massive stars in its central regions. It also has a supermassive black hole at its heart. It is known that quenched galaxies mostly have a supermassive black hole, and that quenching starts first at their centers, she says. NCG 1097 provides an ideal laboratory because it could help us catch it in the act of quenching. In a paper published in the journal Nature Astronomy, Tabatabaye's team combined pictures from the Hubble Space Telescope with observations from two of the world's largest radio astronomy telescopes, erased the Very Large Array in New Mexico, USA, and the Atacama Large Millimeter-Submillimeter Array in Chile. These observations allowed them to map radio emissions associated with electrons trapped in magnetic fields, and compare them to visual images of active star-forming regions. What they found was that large magnetic fields, probably enhanced by the central black hole, affect the gas clouds that would normally collapse into stars, thereby inhibiting the collapse. These forces can even break big clouds into smaller ones, she says, ultimately leading to the formation of smaller stars. All told, she adds, the finding is important because it helps explain cosmic evolution and the way galaxies evolve. Not to mention that if all our own galaxy's star-forming matter had been gobbled up 12 to 13 billion years ago, we humans would not be here today, circling a much younger star, wondering why we exist.